So I know you guys are missing me today while I am sitting grading final exams for the other pre-calc classes, but I didn't want you guys to get behind because we've missed enough days as far as wind days and snow days, and so today we're going to do a little determinant via video lesson. So today I'm going to talk about how you find the determinant of a matrix. We're going to start off with a 2 by 2 and then we're going to look at a 3 by 3, but I won't ever ask you to do more than a 3 by 3. So the determinant has many uses. First of all, the determinant of a matrix is just a number. So after you find the determinant, you're just going to have a value. These are used on square matrices. So if you had matrices of order 3 by 2, you wouldn't find the determinant of it. We're just focusing on our square matrices here. So there's different ways that you can note a determinant. Sometimes you will see it written like here, it'll say DET and then in parentheses it'll have the uppercase letter that's representing the matrix. Sometimes it'll be written so that it looks like almost like an absolute value here. So it looks like that. So in order to find the determinant, a 2 by 2 is really easy, and in fact we've actually already done this in earlier units, you just didn't know it yet. One of the ways that you can use your determinant is to figure out whether or not your matrix has an inverse also, so we'll look at that in a minute too. But in order to find the determinant, you're basically going to multiply diagonally, and then you're going to subtract, you're going to multiply diagonally the other way. So if you'll notice, it takes the A1 position and the B2 position, multiplies those, and then subtracts the A sub 2 times the B sub 1. So on the next page, gives you a little diagram of how that's done. So if you'll notice, it's kind of a diagonal multiplication, and then you subtract and you multiply diagonally the other way. Almost like a cross multiplying. Okay, so we're going to find the determinant for each one of these matrices. So when you multiply diagonally, you're going to do 2 times 2, so that's going to give you 4. And then you're going to subtract 1 times negative 3, which is negative 3. And that's going to turn into 4 plus 3. So the determinant for this is going to be 7. Okay, and then that's all you have to do. Now in the next one, when you multiply, you get 4 minus 4, so that gives you 0. So when you have a determinant of 0, it means that the matrix has no inverse. So this matrix has no inverse. So it's a quick way for you to check a 2 by 2 matrices. If you are asked to find the inverse of the matrix, if it exists, you can quick check the determinant. If the determinant's 0, then you know it has no inverse. Okay, and then the next one, we're going to get 0 minus 3, so the determinant would be negative 3. Okay, so 2 by 2s are pretty easy. It's basically a multiplying, subtracting, and then you're done. As your matrices get larger, it gets a little bit more difficult. So let's take a look at a 3 by 3. So we need some other values which are referred to as minors and cofactors in order to help us determine the or find the determinant. So to find the determinant of a square matrix of 3 by 3 or higher, we have to find these minors and cofactors. Okay, so it's easier if I just show you. There is a pattern for your cofactors. So first you find the minor values and then you find the cofactors. Basically the cofactors just follows these sign patterns. So we're basically going to focus on these 3 by 3s right here. So this is the one that we're going to focus on right here is the 3 by 3 matrix. So plus minus plus minus plus minus plus minus plus. Okay, so there's that pattern. So let's go ahead and find some minors, shall we? So here's our matrix. And in order to find the minors, we're going to get rid of a column and a row. Okay, so for example, if I get rid of the first row and the first column, it's going to leave me with just a 2 by 2 matrix in which I can find, use the determinant of a 2 by 2, and then that's going to become one of our minor values. Now, when we first talked about matrices, we said that when you named a position, you named it by the row and then by the column. So this stands for the minor in the first row, first column. So I'm going to cross out the first row and the first column. And I'm going to say -1 minus 0. So that's going to be -1. So the next one I'm going to do first row, second column. So I'm going to cross out the first row, second column. So I'm going to do 3 times 1, so 3 minus 8. So that's going to give me -5. And then I'm going to do the minor for the first row, third column. So I'm going to cross out first row, third column, 0 minus -4. So that's going to give me a 4. Then I'm going to start on the next one. So now the next one is going to be the second row, first column. Then it's going to go second row, second column. And then the minor for the second row, third column. So again, now I'm going to cross off the second row, first column. So 2 times 1, so 2 minus 0, so that's going to be 2. Then I cross off second row, second column, 0 minus 4, so -4. And then second row, third column, 0 minus 8, so -8. Now I'm going to start and I'm going to do the third row, first column, third row, second column, third row, third column. Okay, so third row, first column. So I'm going to do 4 minus -1, so that's going to give me 5. Third row, second column, 0 minus 3. Third row, third column. So that's 0 minus 6, so that's -6. So these are all of your minors. Now to find the cofactors, what you're going to do is you're going to use that pattern of the positive and negative signs. And then you're just, so the signs go plus, minus, plus, minus, plus, minus, plus, minus, plus. So some of these are going to change, some of them are not. So the cofactor for the first row, first column, that's not going to change because it's still going to be a positive times a negative. So that's going to stay -1. Okay, now the next one's going to change because that's a negative and then that's a -5. So that's going to change to a +5. And then the next one's going to stay the same. In the second row, first column, that's going to change to a -2. That's going to stay -4. That's going to change to a +8. That's going to stay 5. That's going to change to a +3. And that's going to stay -6. Now you need these cofactors in order to help you find the determinant. Okay, so, and there is a shortcut. You don't, when you go to look for the determinant, you don't have to have all of the minors and all of the cofactors for a 3x3. Okay, so now on the next page, it wants you to find all the minors and the cofactors. So I want you to go through and I want you to find all of the minors and the cofactors. So right now what you're going to do is you're going to pause your video and you're going to find all of the minors and the cofactors for this matrix. So go ahead and pause that. Okay, how did you do? So you might want to take a second here to just pause the video, check all of your minor and cofactor values. If they're not the same as mine, go back and check your math and see if you can find where you made your mistake. Okay, and then when you're ready, you can pick back up. I'm going to go over how to find the determinant of a 3x3. So here's where our cofactors come into play. So if you'll notice, this matrix here was the same that we did, that I did with you, that I explained fully the first time. So it's the same matrix. So I already have all of my minor and cofactor values for this on the previous page. So in order to find the determinant, you can pick any row and then, or you can use any column. and then you multiply it by the cofactors. So for example here, I'm going to pick the first row. So I'm going to use these values in the first row. And I'm going to use the cofactors from the first row. So if I look back at my paper, which you cannot see, I'm turning back my paper, and I see my cofactors are -1, 5, and 4. So you do 0 times -1, so that 0 is from the matrix, the -1 is the cofactor. Then I'm going to add the 2 from my matrix, the 5 is my cofactor, the 1 from my matrix, and the 4 is my cofactor. So then I'm going to multiply those. So 0 plus 10 plus 4. So that's going to give me 14. So the determinant of that matrix is 14. It's not equal to 0. Therefore, I know it has an inverse. Okay. All right. Now, we're going to take a look at the next one. In the next one, if you'll notice, it's the same matrix as you did on your own. Okay. So you can pick any row, any column. Let's pick the middle one for this one, just for fun. Okay, so I need my cofactors. So let's just scroll back up here quickly. The cofactors for that for 24, 22, and -7. So you just do 3 times 24 plus 2 times 22 plus 1 times -7. So then let's see, we have 72, we have 44, and we have -7. So then if you add those three together, you end up with a determinant value of 109. Obviously not equal to 0, so therefore it does have an inverse. Okay, I'm not going to get into the 4x4s. It's a lot of work. I won't test you on it, so there's really no need to get into those. But it is a very multi-step process here. So the most I will ask you is the determinant of a 3x3. So you'll have to know how to do your minors, your cofactors. But again, you don't have to do every single minor and every single cofactor because you only end up using one row or one column in order to find the determinant. Okay. All right, so you guys have a Math Excel assignment on your determinant. The review and the answer key is posted, so if you want to get a head start on that for your test, you can go ahead and do that. I know that you will be good little angels while I'm gone, and I will miss you terribly, and I hope you guys have a great weekend.